In this video, we start with the nomenclature or the naming of some compounds. Now, there are about 4 million compounds known, so it's very important to have a systematic way to name them. Okay, so here in the next few videos, we're going to establish the rules for naming some of those compounds. Now, the first type of compounds that we're going to be naming are ionic compounds. Okay, so those are formed by interaction of an anion with a cation. Now, we're going to keep things simple to start with, and just start with binary ionic compounds. Binary means that there's only two elements, and those elements, one will be a cation, and the other one will be an anion. Within binary ionic compounds, there's actually going to be two classes of compounds that are named a little bit differently. Okay, the first class of compounds is what we study in this video. Now, the first class of binary ionic compounds are formed mainly by cations that are formed by atoms that are in these two columns, and then anions that are formed by those elements. Okay, there are some exceptions to that, which will be aluminum that forms a cation, zinc, and silver. Okay, but here are the other rules. Okay, again, the cations come either from here, okay, these two columns, and then aluminum, zinc, and silver. Now, if the cation is from the first column, it's going to have a +1 positive charge. Okay, if it comes from the second column, it's going to have a +2 positive charge. Aluminum will have a +3 positive charge, and then zinc will have a +2, and silver will have a +1. Okay, that is important for the name of the compounds, and actually to know how the formula actually is. Right. What about the anions? Again, the anions are also going to be formed by these atoms that are in the main group, and these halogens form -1 anions, oxygen and sulfur form -2 anions, and nitrogen and phosphorus form -3 anions. Okay, so from here we can actually start to write here some compounds between those cations and anions, and then we'll establish the rules for naming them. Okay, so for example, imagine that we take sodium, okay, and then chlorine. Okay, so that will be the compound formed by sodium and chlorine. Now, sodium belongs to the alkali group, chlorine belongs to the halogen group. Okay, so the charge of sodium will be +1, the charge of chlorine will be -1. Okay, so overall this compound is neutral. Okay, so how do we name this compound then? Well, the way that we name these compounds is first we name the cation, and we use the same name as the element has. Okay, so the first thing that we name in this compound will be sodium, the cation, and again we don't alter that name at all. We're just going to say sodium. Okay, now for the anion, we name it second, and then we add the suffix "ide" at the end. Okay, so that will be from chlorine, that will be changed into chloride, right? So this will be the compound sodium chloride. Okay, let's name a different compound. Let's, for example, name now the compound between potassium and sulfur. Now, potassium is also an alkali metal. That means that it has a charge of +1. Then oxygen, or sulfur in this case, has actually a charge of -2. Okay, that means that in order to have charge neutrality, you actually need 2 potassium ions that are +1, so that your total positive charge is +2, and that balances the -2 charge of sulfur. Okay, so how do we name this compound? Well, that is going to be potassium sulfide. Potassium sulfide. Okay, that's the name. All right, let's rate a few other compounds here. We're going to take, for example, magnesium and nitrogen. Okay, magnesium is an alkaline earth metal, and it has a charge of +2. Then nitrogen is in this group, and it's going to have a -3 charge. Okay, so in order to make things be neutral, then you actually have that the compound must be like this. Okay, notice that 3 multiplied by +2 will be a +6 charge, and then 2 multiplied by -3 will be -6 charge. Okay, that is the simplest combination of whole numbers that give you an electrically neutral species. Okay, so how do we call this compound? Again, we start first with the cation. That will be magnesium. Again, no change to that name. And then we finish with the anion, and add "ide" to the end. So there will be magnesium nitride. Okay, so like that you can continue to name all of the elements that you wish here. Okay, so we can take, for example, cesium and phosphorus, or cesium and oxygen if you want to. Okay, so or we can do very many things here. I'm trying to find here an example that we haven't seen yet. For example, we can take calcium and then bromine. Okay, so calcium is in the alkaline earth metals, okay, and then bromine is a halogen, so then the formula must be like this. Okay, 2 by -1 is -2, calcium is +2, so that is electrically neutral. Okay, and then the name of this compound will be calcium bromide. Okay, and again, with these simple rules, you can continue to name compounds that are formed by cations that come from these two columns, and then the exceptions are these three, which are also named like that, and then the anions come from this part of the periodic table. Okay, in the next video, we actually talk about ionic compounds that are formed by metals that are right here, not in the main group, and how that differs from this naming convention that we just had agreed on.